Click on the air supply panel to set up the bleed configuration as shown in this example. If performance is not limited, we must then consider if engine anti-ice is required. If engine anti-ice is required, takeoff is performed with engine air 4 only selected on to provide control to the discharge valves. Takeoff is not permitted with engine bleeds on and engine anti-ice selected on. Click on the air supply panel to set up the bleed configuration as shown in this example. If engine anti-ice is not required, takeoff is performed with engine airs and Pack 1 and Pack 2 selected on. If this configuration is used, cabin air must be set to recirculate to minimize performance loss. Click on the air supply panel to set up the bleed configuration as shown in this example. If engine air was not used for takeoff, it should be switched on after takeoff and APU air switched off. When APU air is switched off, check that the APU valve not shut and APU non-return valve leak annunciators are out. The APU may then be switched off. Do it. Under normal conditions, no other changes to air supplies will be necessary in flight until the aircraft is being prepared for landing. Where possible, engine air should be used for landing to reduce APU usage. With engine air on, performance will only be limiting in conditions of high temperature and high altitude during a go-around. Engine air on is also not permitted with engine anti-ice on during a go-around. The procedure for deciding how to break up the air supplies for landing is similar to that used for takeoff. If engine anti-ice is not required during the approach and go-around, we must refer to the performance data to see if the go-around performance is limited. If performance is not limited, then engine airs and Pack 1 and 2 remain on and the cabin air is selected to recirc. Click on the air supply panel to set up the bleed configuration as shown in this example. If engine anti-ice is required or performance is limited, then APU air is selected on if it is available and engine airs are selected off. Click on the air supply panel to set up the bleed configuration as shown in this example. However, if the APU is not available, then Engine Air 4 only is selected on. Click on the air supply panel to set up the bleed configuration as shown in this example. Where possible, air switching should be completed by 500 feet AAL. Air switching must be completed by 200 feet AAL. If the APU has not been started before landing, it may be started once the aircraft is on the ground to provide air conditioning after main engine shutdown. Between 2 and 5 minutes after APU power available illuminates, APU air can be selected on. Engine air can now be selected off. If the APU is to be shut down, both packs and APU air should be selected off first. On ground, the APU is shut down via the APU overspeed button on the ground test panel. If the air supply temperature or pressure exceeds their limits, the associated air valve will automatically close. This will be indicated by the engine air fault annunciator. The engine air valve annunciator will light to indicate that the valve has automatically closed. Engine air fault will remain lit for 60 seconds after valve closure and will then extinguish automatically. The relevant engine air switch should be selected off. After 30 seconds, it may be selected on. If the engine air fault annunciator remains extinguished, the system may be used as normal. If the engine air fault is lit again, switch engine air off at the affected engine and leave it off for the remainder of the flight according QRH. The remaining engine's bleed air can supply the rest of the system on the affected side. Congratulations! You have now completed this module.